Welcome to a new playlist. This is basically the optics playlist. Yeah, we just started a new playlist for optics, and first we are going to discuss geometrical optics, or popularly known as ray optics. So, this word, the light ray, is a critical word. What is a light ray? We all know light, different colors of light, visible light, got different wavelengths, and there is a difference between the wavelengths. But if we can make a mathematical model, अगर एक मैथमेटिकल मॉडल बनाएं जिसमें लाइट के वेवलेंथ को या किसी भी इलेक्ट्रोमैग्नेटिक वेव के वेवलेंथ को काफ़ी छोटा कर दें, if the wavelength of the light is a small comparison compared to zero, tends to zero, then light travels along a straight line. It behaves like a vector, an arrow, and light travels along a straight line in a single medium until the medium doesn't change. Nothing happens. You can consider this medium as uniform and isotropic, and in such a case light can follow a straight line path, and then this mathematical model called light ray is considered when wavelength is quite small, not the obstacle or not the aperture, whatever be the size of aperture. If the wavelength of the light is very small compared to zero, it tends to zero in fact, then you can always assume that the light can travel along a straight line in a uniform and isotropic medium. And then comes the concept of ray optics. Ray optics serves you in many ways. अलग अलग तरीके से रे ऑप्टिक्स का यूज़ करते हैं. बेसिकली वी यूज़ इट फॉर tracing image tracing of an object. Object can be a point object, yes, everything starts from a point object, or an extended one, that means you can take a body also. And there are two processes through which the image of an object is traced. One is called reflection. We are all familiar about the laws of reflection, and it simply says there are two laws in fact. If you got a surface, basically it's not a surface, it's a tangent to a surface at a point, and if this is the tangent, draw a normal to the surface and make way to the incoming light. This is called the incident light ray because energy is traveling along a straight line. So call it an incident ray, and it will get reflected like this. And here the first thing is most important, that the incident ray, normal, and the reflected ray all lie in the same plane. And the second thing, this is called the angle of incidence, and this is called the angle of reflection, and they will be same. This can be proved in many ways. You can prove it by Fermat's principle, the principle of extremum, or you can prove it through an imperfect theory called Christian Huygens principle. And we will do it, but not right now, since we are just starting, and I will try to explain one day that lambda tends to zero concept because it's an important concept, but you need to know many things before reaching to this result, that if lambda tends to 0, you can treat light as an arrow, a vector. So the important thing I'm going to discuss right now is how you can trace, how can you use the principle of reflection, and you can trace the images of an object. Reflection as a tool to trace images of object. One such tool is a plane mirror. So I will start from it. Suppose we have a plane mirror silvered from this side, and this side is reflecting, and you get an object here, and there are infinitely many light rays coming out of this, diverging from this point object. So it's a source of light, some kind of source of light. If it is not, it can at least reflect light, but right now it is a source of light, and you must take two rays and make them reflect on the mirror. एक ये रे गया, normal के long गया, normal के long वापस आएगा. You take the second ray like this, it just strikes the mirror, gets reflected. These two angles are same. So this is your reflected ray 1 and this is your reflected ray 2. To trace the image on an object, you only need two reflected rays. The first one is this and second one is this. Because if you try to see from here, from this side, if your eye is in this side of the mirror and you are watching the reflected rays in the mirror, you will have an impression that the rays are coming from this point, though there is nothing. If you put a photographic plate here, you will get nothing, because no light, no energy reaches here, so there will be no mark of any energy on the photographic plate. So these images are called virtual images, because no energy is reaching here. And little of the things are geometry. Simply you can see that these two reflected rays are coming from this point. At least it will appear to you as a प्रतीत होगा कि ये दोनों reflected rays इस point से आ रही हैं. So you will think that there is an object here. For you, this is the object. For us, the tracers, the image tracing people, this is the object and this is the virtual image. And this is the mirror. For you, this is your object. You are looking that there is some object, rays are coming from it. And for us, this is the image of this object. And rest of the geometry you can do yourself. If this angle is alpha, this angle will be alpha, this angle will be alpha, and so this angle will be alpha, and there are two triangles with us. And this side is common and this angle is same, though, so these two triangles are congruent. That means a plane surface, that is a plane mirror for us. It always make the image of an object at a point behind the mirror, which is at the same distance from the mirror as is the object itself. जितनी दूर पर ऑब्जेक्ट है मिरर से उतने ही दूर पर ऑब्जेक्ट के ठीक सामने प्लेन मिरर इमेज बनाएगा उस ऑब्जेक्ट का. You can reverse things. Well, silver this mirror like this and put your object here, and technically you can still trace the image of this object, though if it is source of light itself, lights are emitting from this point, lights are reaching to this mirror, but this side of mirror is not able to reflect the light coming to it. So this mirror is not able to make image of this object, but we can. Mirror is not able, but we can, because we got a brain here. We can do one thing, we can see this point, make some mind maps, and we can take a laser beam and direct along this line. Just focusing on this point, we directed a laser beam on the mirror. Mirror will reflect the mirror beam like this. Then we can do one thing again. We can make our mind maps, and we can guide another beam, another laser beam to the object, but it will reach up to this point, up to the mirror, and it gets reflected here like this. And so this is reflected ray 1 and this is reflected ray 2, and here the image of this object will be formed. Technically we form the image of this object, and this is the real image, because if you place a photographic plate here, photographic plate will feel the intensity of two reflected rays here, and a dot, an illuminant point. This point of the photographic plate will be illuminated, and you can see here the image in form of a point. So you make virtual image of an object, and you can make a real image of an object. So image tracing is your job, not mirror's job. You can do it with the help of image, and that is we humans usually do. We make machines. Machines do not make anything. We make them with the help of machines, because we know how to use the machines. So these are the things. Now if you want, you can do another things like this. If you, this is a wall, empty wall, and here is something, that is the floor, and this is the wall, and someone is sitting here. That's right. And the person got a plan that he is going to fit a mirror on this wall to see his image, full size image, full length image. So you know the nature of the plane mirror? It makes images point to point, आमने सामने. So if you put a plane mirror here on this wall, it is going to make the image of this point here and this point in front of here. Yeah. So mirror is going to make an image of same height as the object is. And you need a mirror. And I guess you have an eye level always below the head level. You have the eye level. So your eyes are here. So what needs to happen here, that the top edge of your head should be able to make a reflection from the mirror, so that the ray coming from this should enter in your eyes. लाइट रे यहाँ से आ रही है, रिफ्लेक्ट करने के बाद आपकी आँख में घुस रही है, and so should be something like this. The rays coming from here should enter in your eyes, and you know where to place the mirror. If you can place the mirror here only, you are going to get your full size image. Or you can do one thing. These are complex to do everything. Every time you can do one thing. You can just extend these lines. And you know, this line is going to meet this point, this line is going to meet this point. So next time when you do this, try to find a mirror for your full size image. And you have decided the wall. You know, if you are here, your image will be here, same distance from the wall where you are going to fit your mirror, and then find your eye level. Just join the top of the image and bottom of the image to the eye level, and you will know where should you place your mirror. And like this, you can find mirrors for your images, and you know to how the mirror helps you to make the images. You know these things. So I'm going to clean the screen, and then, though I can discuss many things, but I would like to discuss it through the problems. So I'm going to give you your first problem here. This one. This picture at your screen, where you can see, here is a problem. A person of height is not equals 1.8 meter. 1.8 meter stands in front of a vertically hanging mirror at a distance L equals 2 meter, or some distance from it. This distance is 2 meter. Okay. His eyes are at a height delta H equals 0.1 meter eye level. Yeah. From the top of its head, top of his head. Oh, it's a man. So, part one of the problem is that what minimum size X of the mirror he can himself, what is the minimum size of the mirror, minimum length of the mirror, so he can see his full image in the mirror. That is a problem number one. And the second problem is, what are the coordinates of the upper y2 and lower y1? What are the coordinates of the upper and lower edges of the mirror? Oh. And sees what part of the reflection will disappear if a person of height h1 equals 1.5 meter. Oh, this is 1.8 meter and this is 1.5 meter. The height of the person changed. Another person came, is placed in his place. What portion, what part of reflection, what length of reflection will disappear in such case? Mirror is the same, but the person height has been changed. So part of reflection is going to disappear. You have to find that length. So these are the problems. So h1 delta h is not y1 y2. These are things I well understood the problem. So we need to solve them. So here is the wall, this is the surface, and this is the person standing of height h0, of course. This total height is h0 and his eyes are a level delta h below. This is the eye level, and this is the image of the object of the man of same height. And now you have to find the mirror. So as we did earlier, we are going to draw a line from eye to the bottom of image and eye to the top of the image, and these are the points in between which the mirror should be placed. And this, I guess, is the height y1, and this is the height y2, and we need to find the length y1 and y2. So we are going to use similar triangles like in this picture. This length is y1 and this length is L given in the problem, and this length is surely h minus h0 minus delta h, this length, and this whole length is 2L. So I can write a perpendicular by base. This is y1 upon L equals h0 minus delta h upon 2L. L gets cancelled out, and we get y1 equals h minus delta h upon 2. So put them all together and you will get the result. The result I got is y1 equals h0 minus delta h upon 2. And now we need to find y2, this height y2. So we are again going to use this, or simply not simply we are going to use these two triangles. The bigger one is this and a smaller one is this, and this is a smaller triangle. This height is h0 minus y2, so h0 minus y2 upon L, perpendicular, it is perpendicular upon base, and this height is delta h upon 2L, the base, and L is cancelled out again, and we can write 2h0 minus 2y2 equals delta h. That means 2y1 equals delta h minus 2h0. That means y1 equals delta h minus 2h0 by 2. No, delta. This is 2y1 delta h minus 2h0. Delta h oh no, I made a mistake here. Sorry. Here 2y1 equals 2h0 minus delta h, and that means y1 equals h0 minus delta h by 2. This is not y1 basically, this is y2. So I made a series of mistakes, but I got the length equals length y2 equals h naught minus delta h upon 2. So these are y1, the coordinates y1 and y2, and now we need to find y2 minus y1 to get the length of the mirror, and y2 minus y1 is nothing but h naught by 2. So the mirror length is simply half of the length of the man itself. So we got these results, the part 1 and part 2 of the problem, but there was a part 3 also. And what was this part 3? In fact, part 3 of the problem is what part of the reflection will disappear if a person of height h1, if the person of height h1 equals 1.5 meter, that is less than, so 1.8 meter, that means h1 is less than h1 is less than h naught, is placed in its place, and the mirror remains at the same place. So this is the mirror, and I guess in this case the person's height will be at this level, the person's eye level will be at this level, at a height h1 minus delta h up the horizontal surface. So this is the eye level of the object of height h1, that is 1.5 meter, and if this mirror is going to plane its image, the image will be found like this. So this length is missing, and what is this length? The missing length that is required is this length, and this length, you can see the similar triangle here, and this length is this. And what is this length? The whole length being h naught, and this length being simply h naught minus delta h. And if we subtract this length, and that is h1 minus delta h, h1 minus delta h, then the result we got is h naught minus h1. So the third part is also solved. There are kind of problems, not difficult though, but we can solve them simply using basic concepts. There are more to come. My left leg is hurting like hell, so I get diverted all the time. So I will do it when I'm fully fit. That means 1 or 2 days hurting because I have some kind of stretched muscle in my left leg because I ran. I'm basically a marathon runner, so it happens sometimes. Thank you very much for watching.